Welcome students, chapter 2 ICC 10th standard physics. So in work, energy and power, work. So what do we do in our daily languages? We use word work for some sort of exertion or physical or mental at times of various activities. While trying, we say that we are doing work. But in physics, the term work is used in relation to the displacement produced by the force. This work is said to be done only when a body moves under the influence of force. If there is no motion produced in the body, even when a force acts on it, the work is said to be zero. So the definition for work is said to be done only when the force applied on the body makes the body move. That is, there is a displacement of the body. So for example, a man while pushing a car. So if the car moves a distance, then only the work is said to be done. If the boy or a man who is trying to push the car and car does not move, then the work said to be done as zero. So we'll take to the example. We'll take few examples from the internet. So we'll see this. See here. See here, we have three conditions when work done can be zero. The first condition is, see here, the lady, okay, she has lifted the bag and the force is acting perpendicular to her, but she is not moving from that place. She's standing here. So the displacement is zero. So the first condition can be when displacement is equal to zero, then the work done can be zero. In the second case here, see here, the lady has taken the bag and she started to walk. So here the force is acting here and the displacement is acting here. So the angle over here, the angle formed between the force and the displacement is 90 degree. So when the angle is 90 degree, that is cos theta will become 0. Then the force or the work done is 0. In the third case, like now, here is trying to apply the force, the angle is there, the displacement is there, then we can say the work is done. So three cases, the work can be zero. One is when there is no displacement, when there is 90 degree, that is theta is 90 degree, and third case is not here, when the force is not at all applied. If force is zero, then also displacement can be zero. So now, so work done depends on two things. What are they? The magnitude and the direction of the force. Second one is the displacement it produces. We'll try to go with the examples. When a coolie carrying some load on his head moves vertically, moves horizontally, no work is done against the force of gravity because the displacement of the load is normal to the direction of the force of gravity, which is vertically downward. The coolie does work against the force of friction when he moves with the load. When a body moves in a circular path in a horizontal plane, no work is done since the force of the body is directed towards the center of circular path. That is, the force is the centripetal force, and the displacement at all instants is along the tangent to the circular path, normal to the direction of the force on the body. It is for this reason that the circular path, the speed of the body does not change although a force acts on the body. Further, in one complete rotation, the total displacement of the body is zero. So the work done in one complete rotation is zero. So they can ask you in the board exam. So list the conditions when work can be zero and give two examples when work is zero. So as explained now, just now I have given you the examples as well as the conditions. So you can write those conditions and examples. Work done by the force of gravity. So that is given by mgh. Let a body of mass m move down through a vertical height h, either directly or through an inclined plane. The force of gravity on the body F is equal to mg acting vertically downwards, and the displacement in the direction of force is h. Therefore, the work done by the force of gravity is mgh. Thus, the work done by the force of gravity is the same whether a man comes down from a certain height using a stairs or a slope or a elevator. So now when can this be taken as positive mgh? When can this be taken as minus mgh? So when a ball of mass m is thrown upwards from A to B, that is from the ground level, you're throwing it up. Think that one more person is at the first floor. So then the ball is doing the work, or the displacement h is upward, is opposite to the direction of force of gravity, and so the work done by the force of gravity mg in displacement h is minus mgh. Then it is taken as negative. The units of work. The units of work are joule and erg. So how do we define 1 joule? 1 joule is equal to 1 Newton into 1 meter. So what is 1 erg? 1 erg is equal to 1 dyne into 1 centimeter. So how do we define 1 joule? 1 joule of work is said to be done when a force of 1 Newton displaces a body through a distance 1 meter in its own direction. What happens with respect to erg? 1 erg of work is said to be done when a force of 1 dyne displaces a body through a distance of 1 centimeter in its own direction. What is the relationship between joule and erg? 1 joule is equal to 10 to the power of 7 erg. Next is power. So what is power? The rate of doing, or the rate of doing work is called power. So the power spent by a source, okay, the power formula is work done by time taken, okay, W by T. Power spent by a source depends on two factors: the amount of work done by the source and the time taken by the source to do the work. So we'll take an example. If we have two coolies, coolie A and coolie B. If a coolie A takes 1 minute to lift a load to the roof of a bus, while another coolie B takes 2 minutes to lift the same load to the roof of the bus, the work done by both of them is same, but the power spent by coolie A is twice the power spent by coolie B, because coolie A does more work or faster work, that is in less time. Now the unit of power. The unit of power is watt. That is SI unit of power. So what is 1 watt? So if 1 joule of work is done in 1 second, the power spent is said to be 1 watt. So we have one more unit of power, that is horsepower. So 1 HP is equal to 746 watts. So now we'll try to understand what is the difference between work and power. Work done by a force is equal to the product of force and the displacement in the direction of force. Power of a source is the rate of doing work by it. So work done does not depend on time. Power spent depends on time. SI unit of work is joule. SI unit of power is watt. The next is energy. What is energy? Energy is the capacity to do work. The energy of a body is the capacity to do work. So what are the units of energy? The SI unit of energy is joule and CGS unit of energy is erg. The bigger units are watt hour, kilowatt hour. And now the difference between energy and power. Energy of a body is said to be Energy of a body is its capacity to do work. Power of a source is the energy spent by it in 1 second. Energy spent not does not depend on time. Power spent depends on time. SI unit is joule. The SI unit is watt. I've picked some images which shows kinetic energy and potential energy from the internet. So we'll go into it. So mechanical energy and its different forms. So the energy possessed by a body due to its state of rest or of motion is called mechanical energy. So in general, when you're defining what is mechanical energy, so in that we have two forms, that is kinetic energy and potential energy. The total mechanical energy of a body is equal to sum of its kinetic energy and potential energy. So kinetic energy is given by a formula of mv square. So the energy possessed by a body by virtue of its state of motion is called kinetic energy. So it is denoted by capital K. A fast moving stone has the capacity of breaking a window pane on striking it, and thus it has kinetic energy. Similarly, a car in moving hands on a clock, the bullet fired from a gun, a rolling ball, an apple falling from a height, etc. have kinetic energy. So Quantitative value of kinetic energy. The kinetic energy possessed by a moving body can be measured by the amount of work which the moving body can perform before coming to rest. To calculate it, an opposing force is applied to stop the body and the amount of work done by the opposing force is calculated. So now we have half mv square. Kinetic energy is half into mass into square of velocity. So now here what happens is, so work energy theorem, what does it say? When a force is applied in the direction of the motion of a body, it accelerates the motion and thus increases the kinetic energy of the body. This increase in kinetic energy is equal to the work done by the force of the body. According to the work energy theorem, the work done by a force on a moving body is equal to the increase in its kinetic energy. So we have few images. See here. Here it is showing. See here. So initially, when this fellow is standing here, this is this contains potential energy. So what is potential energy? The energy possessed by a body by virtue of its specific position. Okay, by its position. So potential energy. As he comes down, because of the virtue of its motion, it gets kinetic energy. Total potential energy is converted into kinetic energy. Okay, now the ball, when it is holding here, it has full potential energy. So when she leaves it and comes down and reaches here, so then it gains, as it is moving, it the potential energy is converted to kinetic energy. We have the law of conservation of energy, which says that the energy can neither be created nor be destroyed. It can only be converted from one form to another form.